Let's take another example. Suppose we have an amount of money today that presently we have, say, $22,576. We have this money today, and we want to know that if we invest this amount of money in a bank account which pays an annual compound interest of whatever, like 7.32% per annum, and if we deposit this amount of money at 7.32% per annum for a time period of 9 years and 6 months, means 9.5 years, how much money shall we have at the end of 9.5 years? So this is to solve this problem, we need to draw a timeline. So let's draw a timeline of about 9.5 years. So for example, this is time 0, this is the end of first year, and the end of second year, the end of third year, and let's do it like this, that this is the end of 9th year, and this is 9.5 years. So we want to know that if we have an amount of money which is 22,576 at time 0, and if we deposit this amount of money at a compound annual interest rate of 7.32% per annum, how much this money would become at the end of 9.5 years. Now to solve this, we shall write the formula of future value, because we want to know how much would be the future value of this amount of money that we have at time 0. So we want to know the future value of this amount of money at the end of 9.5 years. Future value at the end of 9.5 years. So the future value at the end of nth year is equal to the present value at time 0 multiplied by 1 plus annual compound interest rate raised to the power the time duration. So let's put the values in this. Presently we have $22,576 and our compound annual interest rate is 7.32%, that is 0.0732 raised to the power n, the time duration, which is 9.5 years. 9.5 years. Now solve this equation. This is $22,576 multiplied by, now 1 plus 0.0732 is 1.0732 raised to the power 9.5 is 1.9564. Now multiply this with 22,576 is 44,168.565. So this is the future value of 22,576 at the end of 9.5 years. So by applying this formula, we can calculate the future value of any given amount of money at time 0. So if we have any amount of money, say whatever, 2,000, 3,000, 22,000, 32,000, whatever, and we invest it at a given compound annual interest rate for a given time duration, we can calculate the future value of that amount of money. This problem can be posed in different ways. For example, somebody can ask you that I want to have 44,000 $168 at the end of 9.5 years, and my local bank account pays 7.32% compound annual interest. So how much money I need today? How much money I need to deposit in my bank account at 7.32% so that I can have $44,168.56 at the end of 9.5 years. So this is just opposite. To solve this problem, just we shall apply the formula of present value. So present value at time 0 is equal to the future value at the end of time n divided by 1 plus compound annual interest raised to the power n. So just by putting the values in this equation, we can solve, or we can calculate the present value of any given amount of money. Let's take an example of this. For example, I want to have $50,000 at the end of say 7 years, and my local bank pays an annual compound interest. This is small I represents annual compound interest. So annual compound interest of say 6.8%, and I want to know how much money should I deposit today in my bank account so that I can have $50,000 at the end of 7 years. So to solve this, let's draw the timeline again. So in the timeline, at time 0 is the present value that we need today, and we want to find out this value, and this is the end of first year, the end of second year, and likewise this is the end of say 6th year and 7th year. Okay, now I want to have 50,000 at the end of 7th year. 50,000, this is the future value at the end of 7th year. I want to have this money, and if the annual compound interest rate is 6.8%, how much money I need today? That should be deposited in a bank account at 6.8% compound annual interest rate, and it becomes 50,000 at the end of 7th year. Now let's apply this formula of present value. So here the present value at time 0 is equal to the future value at the end of nth year, which is 7 in this problem, divided by 1 plus compound annual interest rate raised to the power n. So just put the values in this formula. This is future value at the end of 7th year is 50,000 in our example, divided by 1 plus annual compound interest rate is 6.8%, which is 0.068 raised to the power n, number of years, which is 7. Now if we solve this, this would become 50,000. Okay, I'm running out of space. So 50,000 divided by, so 1 plus 0.068 is 1.068 raised to the power 7 would become, so I'm doing it on my calculator, right? So this is 1.58584. Okay, now 50,000 divided by 1.584 would become equal to, let me make some space for this. Okay, so pardon me for this. Okay, let me solve it here. So 50,000 divided by 1.584 equals to 31,547.95. So this means that if I have $31,547.95 today at this point, and I invest that money in a bank account which pays 6.8% interest, annual compound interest, I would have 50,000 at the end of 7th year. So this is the way how we can apply this present value and future value formula to calculate the present value and future value of any single amount of money. So make sure that this is the problem related with the time value of money of single amount of money. So in the next video we'll see how to calculate the time value of money for an annuity, for a stream of cash flow.